Right. So, good morning, everyone. So, for today's class, we will be discussing about elimination rate, half-life, and area under the curve. Okay. So, basically, class, last meeting, we were able to discuss some few concepts, okay, some terminologies na dapat aware tayo, okay, before we can start class with our computation. Okay. Now, one thing, class, that I need you guys to be reminded of is that since most of our drugs class available in the market, yung kanyang therapeutic concentration does not reach saturation. Hence, class, our discussion here will focus more on first-order processes. Sa mga first-order muna tayo. Okay? Limited lang kasi, class, yung mga drugs that follows zero-order kinetics. Yung kung saan, class, ang therapeutic concentrations nila is near the saturation point. That's why, class, we're going to give more attention sa first-order process when we do our computations. Especially, class, in the latter parts of our lectures, okay, of this course, okay, we will be discussing more on first order process talaga. Tapos sisingit-singit lang natin ng konti yung zero order process. Right? So, I hope you won't mind, class. During the entire discussion here, I'll be focusing more on first order process. Pero again, isisingit ko naman yung zero order process. Okay? Alright. So, elimination rate constant. We all know, class, that once a drug enters the system, it's going to be eliminated sooner or later. Now, of course, class, whenever a drug is being absorbed, at the same time, it's going to be eliminated at a constant rate. Okay, provided, class, that the drug, again, is following first order process. So, an elimination rate constant, class, represents a fraction of a drug removed per unit time. Now, please take note of the term. The elimination rate constant represents a fraction. Kaya, class, you'll notice, ang unit ng rate constant natin, elimination rate constant, is like 0.05 per hour. Okay? Notice, class, wala ditong milligrams per hour, ml per hour. Walang ganon. Kasi what we're given here, class, is a fraction of the drug that is eliminated with respect to time. So, pag sinabi natin, class, 0.05 per hour, it means 5% of the drug is eliminated every hour. Okay? So, it just represents a fraction of the drug that's being removed. It's not an exact unit. Kumbaga. So it just tells us this amount is being eliminated in a given time. This fraction of the drug is being eliminated at a given time. Right? So the first order process is applicable or of greater use for us here. Okay? As compared, class, to the zero order process, because first and foremost, most of our drugs, again, about 95%, their therapeutic concentration is not near their saturation point. So most of our drugs do not experience saturation at therapeutic concentrations. Hence, class, they follow the first order process. Okay, ilang gamot lang naman, class, ang therapeutic concentration niya ay malapit na malapit sa kanyang saturation point. Right? Now, how do we compute, class, for our elimination rate constant and so on and so forth? Okay, so basically, class, ang ginagamit natin dito is the equation of a straight line, which is y equals mx plus b. This is something taught to us, class, nung tayo ay high school pa lamang. Okay, when we were doing geometry. Where in class, we plot, okay, we make straight lines in a cross-sectional graphing paper. Okay, we're in class, y-axis, obviously, dito yan. Okay, dito sa side na to. This is our y-axis, and our x-axis, class, would be written down here. Okay, ang increase niyan, class, would be, of course, this is the 0 point. 0 point nandito. So, tapos increase tayo pataas for the y-axis. Then for the x-axis, pakanan. Alright? Now, ang turo sa ating class is y equals mx plus b, wherein the y class here refers to any data on the y-axis. Okay, obviously here. Alright? And then yung x naman, class, is yung mga data na nandito sa x-axis, obviously. M here, class, refers to the slope of the line. Okay? So, wait lang. Okay, so where was I? Ayun. So, again, x-axis, class, written on it's the lower portion, obviously the y-axis. Okay, where y class here refers to any data on the y-axis. Excuse me. Okay. M here refers to the slope. Now, the slope here, class, is the steepness of the line. So, how steep is that? Normally, class, pag tumataas, lumalaki yung slope, lumalaki yung value ng slope, it becomes more steep. The less value, the less steep it is. That's the reason why, class, if you get Say for example, ito yung elimination natin. Okay? So the more larger the slope class, ibig sabihin napakabilis ma-eliminate ng damot. Alright? And then of course, the x-axis here would refer to any data on the x-axis, while the y here, the b here is known as the y-intercept. Okay? This is where your x-axis intersects with the y-axis. Okay? Now, yun siya. Now, class, of course, in kinetics, we use the same graph. Okay? We use a graph din naman. Okay? And then, class, we assume that our drug follows one compartment model. So, meaning it's going to yield a straight line once plotted in a semi-logarithmic graphing paper. Yun yung assumption natin here. Okay? Kasi sabi natin, ano bang assumption pag open one compartment model? That body is just a vessel which contains a fluid, tapos ang distribution is instantaneous. Alright? So, class, if I was to convert this data into the data that we usually input in a plasma level time curve, okay, sabihin natin cross-sectional graphing paper muna ha. So, the Y here, class, would refer to concentration. Okay, any data along the, kasi yung sa y-axis dito would be the concentration, right? So we'll write it down as concentration. M here would be the elimination rate. Because as we've said, class, how fast a drug is being eliminated depends on the steepness of the line it creates. The more steep, the faster it's going to be eliminated. Okay, the less steep, then the lesser it is being eliminated. X here would refer to time. Okay? So, usually written in hours, pwede minutes, days, depende. And then the y-intercept here, class. So, ano bang data nandito? Okay? This is the concentration at 0 time. So, meaning this will be my C sub 0. Now, class, of course, this is only applicable kung anong route of administration ang ginamit natin. Applicable lang to, class, if this is an IV route. Now, for the sake of simplicity, class, lahat ng i-discuss ko dito, IV route muna. Wala muna tayong ipapasok na extravascular route or per oral route. Kasi class, kung per oral route yan, it's going to complicate our computations. Kasi normally, if that's given extravascularly, at 0 time, 0 din yung concentration mo at may absorption phase ka pa prior to elimination phase. Right? So, after reaching the Cmax, saka pa lang siya mag-eliminate. Right? As meron tayo ditong absorption phase. Okay? So, for the sake of understanding muna, class, the concepts behind our computations here, we'll start off with IV route muna. Okay? Kasi yun ang pinaka-simplest. Walang absorption rate, diretso elimination agad siya. Okay? So, there's no confounding factors that we have to consider here. Right? So, normally, it would look something like this. Now, if this is class a zero-order process, so, ang turo sa atin before is that as long as the drug is straight line in a cross-sectional graphing paper, then that follows zero-order process. If it's a straight line in a semi-logarithmic paper, okay, then it means it follows first-order process. So hence, class, if I'm going to rewrite this, y equals mx plus b, I'll replace y with concentration, so I'll write down as Cp, meaning plasma concentration. M here would refer to elimination. Okay, so that will be K. Right, elimination rate constant, di ba? Ke yan. Or K. Okay, na lang para alam natin to. Okay, tapos X class would refer to time. So, let's put down as time. Now, one thing you have to consider here, class, is yung elimination rate, yung slope, ano yung direction? Pataas, pababa. Okay, di ba class, pababa? Kasi pa-decrease yung anya, yung value. So, therefore, class, it means our slope should be negative. Hence, class, I need to put a negative sign here. Okay, sa KE ko. Alright, then class plus B, and our B here is the concentration at time 0. Now, just so you know, class, this is the equation for a zero-order process. That is the equation for a zero-order process. Kasi, class, a zero-order process is, is plotted in a cross-sectional graphing paper and it appears as a straight line. Now, what about kung yan ay gagawin nating first order process? So sabi natin, class, sa first order process, we plot our data in a, we call this in a logarithmic paper, semi-log paper. So let me just show you what a semi-log graphing paper looks like. Okay? So it looks something like this, class. Alright? Oops, ang laki pala nito. Okay. Alright. Looks something like this. Now, ang semi-log kasi, class, kung mapapansin nyo, equal yung division sa x-axis. Okay? It follows the standard arithmetic scale. Well, on the y-axis, class, may malaki, tas biglang niliit. Tas malaki, tas biglang niliit. Because this y-axis, class, follows the logarithmic scale naman. Alright? Kasi the semi-log, ibig sabihin, only one axis follows the logarithmic scale. While the x-axis, the y-axis is the only one that follows the logarithmic scale. X-axis follows the arithmetic scale. So every tenths here, class, is a log scale. So meaning, di ba pag logarithm, okay, it's always based on based on the power of tenths. So meaning, class, every scale here should be multiplied by 10 ang value. So halimbawa, I start here as 1. Is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So dahil, again, nag-raise ako ng log scale, so therefore, times 10 na yung mga values here. So 1, 2, 3, 4, 5, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 2,000, 3,000, 4,000, and so on and so forth. Yun yung pag-arrange, class, or yun yung proper way of reading out a semi-log paper. Kasi nga, per cycles of tens ito, per logarithmic cycles. Okay, so it's always based on the power of tens. So yung values niya increase by times 10 lagi. Okay, per scale. Right? Okay. So now, going back here, class, right, sa ating straight line. So, obviously, class, ang nagpa-follow lang ng logarithmic scale ay yung data na sa y-axis. X-axis stays the same. So, therefore, class, if I'm going to convert these data into a first-order process, kailangan lahat ng data na nasa concentration side, lahat ng data na nasa y-axis should be converted or should have a logarithmic expression. Now, in kinetics, class, we do use log, pero kasi kailangan pa i-divide by 2.303 yung ating mga data sa y-axis. So, to simplify that, class, we just use natural log, which is ln, as a means to put logarithmic scale in our, logarithmic functions in our data on the y-axis. So, ano ba yung mga data on the y-axis here? So, CP, obviously, yan yun. Nasa y-axis to. So, let's put ln CP. Slope. Slope, nakalutang lang yan. So, as is pa rin yan. Okay, negative KE. T is obviously time, so wala yan. So, plus CO, C sub 0. So, di ba, sa y-axis din naman yun. So, therefore, lagay mo ng ln C sub 0. And voila! This is now the equation for a first order process. Simple as that. So, are we good? Okay, so that's the equation, class, for a first order process. Now, what about when we're computing for slope? Okay, so slope, class, is, kung naalala pa natin, nung tayo ay elementary pa lamang, or maybe high school, ang equation, class, ng slope is change in y over change in x. So, meaning, class, ang slope natin would usually be y2 minus y1 equals x2 minus x1. So, meaning, class, as long as you have a straight line here, okay, if you have a straight line here, you can compute the slope of the line, class, by using 2 points here. Okay? So, pwedeng gamitin ko yung ito, at saka ito. Ito na lang pala. May data ako dito. Okay? So, I can use this y, y8, okay, ito y4, tapos their corresponding value sa x. So, this is x4, and this is x8. So, kung this is a plasma level time curve, class, then my y8 would be Cp is equal to 8. Then, time niya would be equal to 4. And this one naman, ang Cp niya is 4, while the time is equal to 8. Now, if I'm going to compute for the slope, then obviously, class, I'll just do this. y2, pili ka lang kung anong y2 mo dito, ha. Pero normally, class, you have to arrange this based on highest to lowest number. Okay? Highest to lowest tayo dito. So therefore, this can be 8 microgram per ml minus 4 microgram per ml over 8 hours minus 4 hours. And that would give us 4 microgram per ml over tawag dito 4 din pala, sorry, ano ba yan? Naghang pa ako. So equals to 1 microgram per ml per hour ang elimination rate niya. Now, provided class this is a zero order process. If this was a first order process class, so therefore, ang mangyayari would be, lalagyan natin ng natural log ito, ln, ln. So therefore, that's equal to ln 8 minus ln 4 over 8 minus 4. Natural log class, I don't know if you can see this. Yeah, okay, ito, natural log. Okay, ln. Alright, so ln 8 minus ln 4 will give you 0.693147. I usually just try to write that is 6. 4 class is okay na. Right, divided by 4. Divided by 4, you get dito na ako, 0.17 per hour. Now, please take note, class, once we start adding logarithmic functions here, hindi na considered yung units niya. Okay, so tinatanggalan natin yung units. So, therefore, class, kung first order process ito, 0.17 per hour ang kanyang rate of elimination. So, meaning, 0.17. So, 17% of the drug is being eliminated every hour. Alright? Dito exact kasi. Kung zero order process yan, class, exact yung makukuha mo dito. Okay? So, 1 microgram per ml every hour is being eliminated. Okay? And that's usually how we express a zero order elimination rate. Okay? Again, most of our drugs naman here would be first order process. So, hence, we express it as a fraction of the drug eliminated per in a given time. So, about 0.17 or 17% na lang of the drug is being eliminated every hour for first order. Okay? So one thing we have to consider, class, a negative slope indicates that the natural log of the concentration declines with increasing time. Kaya kadalasan, class, sa ating formula, okay, yung dito, excuse me, we put a negative sign here to indicate that the slope is going down. Okay? So values for K uses usually absolute numbers. Okay, we usually use absolute numbers for this one. Okay, so meaning kung ano man yung value ng K mo, should always be a positive value. And this is, of course, our C sub 0. Now, here's our time at 0 time. Okay, so ito naman ang C1, and then this is our T1. So, class, we can do this also like this. So, yung slope kayo na pinakita ko sa inyo, computation, using 2 points in the line. Now, of course, class, pwede rin naman natin gamitin ang C sub 0 as a reference point. So, that's ln C1 minus ln sub 0 over T1 minus T sub 0. Now, the thing is, class, since this is T1 minus T sub 0, kahit tanggalin ko na to, right? Kahit hindi ko na isulat yan. So, ang lalabas na lang is ln C1 minus ln C sub 0 over T1. Pwede na rin yun. Okay, so, that's one way, class, of simplifying the formula para tipid tayo sa ink ng ating ballpen. Okay? So, pwede rin naman yun. So, we use C sub 0 as a point of reference, as one of the Y values that we use. So, halimbawa, class, in this case, let's use this one. Okay? ln C sub 0 natin is 10. Again, I'm using, class, the largest number first before the lowest para hindi na ako mag-convert. Kasi gagawin mo rin naman positive sign yan. Isulat mo na yung pinakamalaking number muna. Tapos, ln C sub 1, sabihin natin, class, is 4. So, over 8. Rekta ko na 8. Hindi ko na isulat na 8 minus 0 pa. Kasi alam naman natin, 8 minus 0 will give you the same number. So, ln 10 minus ln 4 equals 0.916291. Again, this is just me. Pero as much as possible, don't round off muna. Divided by 8. And you get 0.1145 per hour. Okay? So, pwede na rin. Close enough. Okay? I'm not even sure kung hindi pala to first order process, kaya pala hindi pala applicable ito. Okay, sorry about that. This isn't a first order process because naka-arithmetic scale yung kanyang plasma drug concentration. So, erase. Pero kung sakaling magko-compute tayo class ng first order process, ito siya. Ganito yung tsura niyan. So, obviously, now I've just proven that this is not a first order process. Kasi magkaiba yung elimination rate niya at different time points, using different time points. But let's try to compute it class using zero order process. Alright? So, that would be 10 minus 4 over 8. And that would give us, tama ko, 4 naman, diba? 10 minus 4. Tapos ang time ko is 8. Parang kakaiba. 10 minus 4, 6 yun eh. Divided by 8. 0.5. Microgram per ml per hour. Oh, lalo nagkaiba. Anyway, so yun na siya. Parang weird naman. Ano naman to, diba? 8, 9, 10. Okay, maybe has something to do with the graph itself. Pero hindi eh. 8 and 4. 4 and 8. 8 minus 4 gives you, well, 4. Okay, whatever. Basta yun na yung process ng ano. Has something to do with the graph, probably. Or maybe I'm having mistake somewhere else. Tama naman. 10, 0. Right? Ay, no, it's not 10. 16. What? 16? Wait. Okay, it is 16. I am so sorry. Pero still, still the same. Well, there has to be something wrong with this. 16 minus 4 would give you 12 divided by 8. Gives you 1.5. Okay, pero try natin ito. Ito gawin natin 16. ln 16 minus ln 4 divided by 8. Oh, it's a first order process. Ako yung nagkamali. Oh my goodness. So that's ln 16 minus ln 4. We get, so x to x. Ito yung x. Okay, we get, ba't ako nagganon? Pwede pala mag-eraser. Okay, so let's erase this one. Mali-mali yan. Okay, so again, it's part of the learning process. So at least now we're assured that it's a first order process. So that's 1.386294. And let's erase this one. Okay. Divided by 8, you get 0.1733, which is pretty much close enough, right? Okay. So here and here. So now we know, class, that it is a first order process indeed. Okay. So, sorry, nagkamali ako. Akala ko zero order process siya. 16 pala nakasulat doon. Right? Okay. Now, let's proceed. Okay. So now, class, when we do elimination rate constant, again, it's just ln c sub 0, ln minus ln c sub 1 over t. Now, class, actually, ang t niyan is t1 minus t sub 0. Pero dahil sabi nga natin, 0 lang naman ang value nito, no need to write it down. Okay, so this equation is very important in therapeutic drug monitoring because we are able, as long as you're given 2 plasma drug concentrations, you can determine your elimination rate constant. At dito natin malalaman, class, how often should I be giving the drug? Okay, because if it's eliminated slowly, then obviously I'm going to give my drug less. As compared to when it's being eliminated fast, then I'll give my drug more often. Okay, so if one plasma drug concentration and K is known, then the plasma concentration can, at any later time, can be calculated, which makes sense, right? Meaning, class, as long as I know at least one of the plasma concentrations here, okay, in this line, I can determine, class, the plasma concentration at any point in the line. So, say, for example, if I know here, C1 as 8, okay, syempre, alam ko na rin naman yung corresponding time nun which is 4. Okay, I can determine, class, yung concentration even at, say, for example, on the 16th hour. I can determine that. Provided, class, I know my K. Okay, how do I do that? So, obviously, class, you just have to transpose the formula. Okay? So, transpose natin to. Ang lalabas is ln C sub 0 minus ln C sub 1 equals K times T. Then, gusto ko dito is C lang, CP, or plasma concentration at any given time. So, therefore, that's negative ln CP equals KT minus ln C sub 0. So, tanggalin natin yung negative sign. Multiply both sides by negative 1. You get ln CP equals negative KT plus ln C sub 0. Ay, ano ba? Tama. ln C sub 0 pa pala ito. Now, class, of course, we have to remove the ln here para makuha natin CP lang. So, multiply both sides by the base of the natural log, or with what we call the Euler's number. Okay, para mag-cancel out ito. Kung bagala, class, si log may anti-log. Si natural log may Euler's number, or the base of the natural log. So, hence, you get here CP equals E. Now, class, if you use the Euler's number kasi, anything na tatamaan niya, nagiging subscript. Negative KT. Now, class, ang ln plus ln C sub 0 here, okay, hindi na siya magiging plus na, plus sign. Okay, magiging multiply na, meaning indicating that it's already a positive number. It's going to be a positive number. So, that's times C sub 0. So, rearrange the formula, class. Ang lalabas dyan is CP equals C sub 0 times E negative KT. And this is the formula that we will use to get what do you call this? To get the plasma concentration at any given time. So, try natin. Okay, using the values here. So, kunwari, class, hindi ko alam ang concentration on the 8th hour. So, CP on the 8th hour is equal to unknown, kunwari. Pero alam kong 4 yan. I know it's 4. Right? Now, let's try to compute first, class, for K. Using yung C sub 0 natin. So, that's ln 16 minus ln, kunwari, itong gagamitin ko, ln 8 over 4. Let's give it a try. ln 16 minus ln 8 gives us 0.693147 divided by 4. We get 0.1732 per hour. Okay, pretty much the same yung kinumpute natin kanina. Now, ang sabi natin, gagamitin natin yung equation na to determine the concentration on the 8th hour. So, therefore, class, since may K na ako, may C sub 0 pa ako, meron pa akong T, which is 8 hours, I can determine for that. So, therefore, CP equals, C sub 0 ko is 16 times E raised to negative 0.1732, okay, times 8. So, that's 16 times, sige, isa-isay natin muna. E raised to negative 0.1732 times 8, negative 1.3856. And that gives you, so, shift ln, that gives you E. Tapos input nyo lang number to. Negative, don't forget the negative sign. Importante yan. 1.3856. At ang lalabas ay 16 times, okay, times na lang dito sulat ko. 0.2501736. So, times 16, we get that 4.00277. That's microgram per ml. Okay, so did we get the same number? Oh, yes, we did. Okay, pretty much we got the same value here, right? Now, class, gusto natin malaman yung on the 16th hour, we'll just do the same thing. Except, ang papalitan ko dito, of course, would be T. So, gawin natin 16th hour. Excuse me. So, plasma concentration on the 16th hour, yung hindi natin nakikita dito, kaya ko malaman yun. Alright? So, that would be 16 for CP sub 0 times negative 0.1732 times 16. Sorry ka, shortcut ko na to ha. At least gets nyo naman na to. So, 0.1732 times 16, negative answer, correct ako na, times 0.0625 times 16, you get an answer of 1.00. That's microgram per ml. So on the 16th hour, so plasma concentration on the 16th hour will be 1, approximately 1. So if I was to trace this, most likely andito na yan. Alright. So I hope that makes sense, class. And this is the equation, and this is the formula that we use to determine this. Now, here's another thing, class, na makapapansin ninyo. Remember, class, during our past lessons, okay, ang lagi kong sinasabi ay mahirap i-determine yung actual CP sub 0 or the concentration on the time of administration. Mahirap ma-determine ito. Okay? Bakit? Okay, sabi natin, class, it's physiologically impossible to get that concentration because normally, class, CP sub 0 is an assumed value. We assume this. Okay? So, ibig sabihin kasi, class, di ba, pag IV yan, pag push mo, kuha ka agad ng blood sample, which is, of course, hindi natin ginagawa in practice. Right? So, imposibleng gawin yun. So, therefore, class, how do we derive the plasma concentration at time 0? So, we've mentioned two ways. One, class, is we back extrapolate our existing line, okay, to get an assumed value for CP sub 0. So, ibig sabihin, if I started, class, with concentration C1 here, tas ito, and then I get these four plots, 4 points, okay, gagawa ako ng straight line connecting all 4, okay, line of best fit ang tawag natin dyan. We're just going to fit everything in one line, tapos I'll make a straight line until I reach CP sub 0 here. So, kung saan tumama yan, yun ay CP sub 0 ko. And again, that's an assumed value. Now, another technique, class, that we can use here is, as long as provided tayo ng dose, as long as I'm given the dose, and I'm given the VD, I can compute for my CP sub 0, provided that, again, my drug is given intravenously. Alright? Remember, class, yung sabi ko sa inyo equation na wag na wag niyong kakalimutan, okay, which is CP equals dose over VD. Okay? Kasi ang kinocompute natin na CP dyan, class, is the concentration at 0 time. Siguro naman, given na sa atin lagi ang dose, right? How much of the drug will be given? Ang VD naman, class, makukuha mo yan sa drug lit. You can get this from drug literatures. Alright? So, halimbawa, ang sasabihin sa'yo dyan, ang VD of this drug is 0.2 liters per kilogram body weight. Okay? So, ibig sabihin, you just have to multiply it by body weight. You get the volume distribution of that given drug. Okay? So, pwede yun. Now, that's another technique or another way of getting your plasma concentration at 0 time. Again, class, this is a assumed value. Again, assumption lang to. Okay? Hula-hula lang. Now, what about, class, if you're not given VD, you're not given dose? You're just given a... Sorry, most likely given naman ang dose nito eh. Hindi ka binigyan ng VD ng gamot. Okay? All you are given, class, is the graph. How will I get now my CP sub 0? So, class, similarly to how we get the concentration at any given time, we can actually determine the concentration at 0 time din. Okay? By transposing this formula. Alright? Hindi ko na papakita kasi kung paano ito itatranspose. Ang papakita ko na sa inyo ang final answer dyan, which is CP sub 0 equals C, okay, times E positive KT. Yun lang ang difference, class. Okay? Don't believe me? Oh, sige, let's try this, ha? I'll use class C1 here to determine CP sub 0, which I know is 16. I know it's 16. Alright, wait lang, magbubura muna tayo dito. Okay. Probably, dito na lang magbubura. Alright, hope you don't mind. Let's just erase some stuff here. Okay, yung conversion natin kanina. Yung ating transposition pala, sorry. Okay. Yan. Alright. So, here, class, CP sub 0 equals, let's say, 8. Ang C1 natin. So that's 8 times e raised to positive kt. So hindi ako maglalagay ng negative number dyan. Kaya sabi ko sa inyo, importante yung negative sign na yun. Pag nagdetermine ka ng concentration at any given point in the time. That will give me 0.1732 times ano nga ba to? Ang time ng C1 ko dito, which is 4. Okay? That's 8 times. Okay, diretso na ako 0.1732 times 4. Shift LN answer. You get times na lang to. 1.9999305, etc., etc. So times 8. And we get 15.9944, which is technically 16 na rin. Right? 16 micrograms per ml. Okay? So we got here the same exact value. That's how you can compute class for CP sub 0. Again, class, yung time dito would be the time of the C1. Okay? Kasi yun lang naman dito yung time natin dito. Right? Okay. So that's how you can get class CP sub 0. Again, there are 3 methods. Okay? 1, back extrapolation. Number 2, using the equation CP sub 0 equals dose over VD. That's another way. Provided class, alam mo yung dose and yung volume distribution ng gamit mo. And number 3, gagamit tayo ng equation na CP sub 0 equals C times E, positive KT. Positive yan, positive KT. To get CP sub 0. Again, class, CP sub 0 is just an assumed value. Okay? Okie dokie. So this one, class, I'm going to give to you guys as a seat work, okay, which you can work on your own as part of your asynchronous activity. Okay, same goes with this one. All right. So again, class, this is the formula that we usually use to determine the concentration at any given time. So that's C equals COE negative KT. I've actually discussed this na in advance. Nauna na ako sa slides ko. Okay, so again, class, here's a sample problem. Again, I'll give this to you guys as part of your asynchronous activity. Okay, I've already written down here the answer, class. Just prove to me how you get this answer. Now, for half-life, ano ba yung half-life? Half-life, class, is basically the period of time required for the concentration of a drug to decrease by 1/2. So it is the time required to decrease the initial dose of a drug by 50%, or 1/2 of its original concentration. So why is this significant? Okay, half-life, class, is being used to obtain the dosing interval of the drug to determine or to get a desired CP. So generally, the dosing interval is usually, but not all the time, the same as your dosing interval. Okay, it predicts how long it will take a drug to reach steady state levels. So, gaano nga ba katagal? How many half-lives, class? So, sabi natin, di ba, it takes about 4 to 5 half-lives to reach steady state concentrations. And predicts accumulation of a drug in the body for a specific dosing interval. So, during multiple dosing or continuous IV infusions, it takes approximately 4 to 5 half-lives to reach steady state levels. And also helps us predict how long it will take a drug concentration to decrease to a lower concentration. And approximately, class, all drugs decrease by 96% after 4 half-lives. So, for a first-order process, class, half-life is consistent. Excuse me. So, it is related to a first-order rate. So, no matter what the initial amount is, okay, the time required for the amount to decrease by 1/2 is constant. And the formula, class, is 0.693 divided by your K. So, here's an example, class, of a graph showing to us, okay, half-life. Okay? So, here, class, again, let's try this one. Let's compute, class, for the half-life of this one. Okay, although right now, I know, class, that my half-life is 7 hours. Paano ko nalaman yun? This is a graph, a graph plotted in a cross-sectional graphing paper. So since it's curved, it indicates that it's a first-order process. Okay, in a cross-sectional graphing paper. Kung straight line yan class sa semi-log, then that means it's first order process. Now, kung sa cross-sectional graphing paper ay straight line ito, this looks like a straight line, then that means it follows zero order process. Now, ang half-life ng gamot na ito class 7 hours. How did I know that? 0.2, half ng 0.2 is 0.1. Kailan niya na-reach yun? After 7 hours. Half ng 0.1 is 0.05. Kailan niya na-reach yun? On the 14th hour. Half ng 0.05 is 0.025, somewhere along this line here. At kailan niya na-reach yun? On the 21st hour. So, tuwing kailan nare-reduce by half yung kanyang concentration? It's reduced by half every 7 hours. So, therefore, I know for a fact class that the half-life here is 7 hours just by looking at the graph. Pero let's compute. Okay? Sabi nga natin class, ang unang kailangan natin na value here is K. And you can compute for K provided you have a concentration at 0 time and a concentration at any point on the time on the line here. So itong gamitin natin 0.1 on the 7th hour. That's ln 0.2 minus ln 0.1 over 7 0.2 minus ln 0.1 rectangle to class, divided by 7, you get 0.0990 per hour. That's for K. Sabi natin, half-life, 0.693 divided by K. 0.693 divided by 0.0990. 0.693 divided by answer. And you get 6.9985 hours for half-life. Or, we just simply assume it's 7 hours. See? That's how we compute class for half-life. Okay? So, half-life can be calculated from 2 plasma concentrations after a dose is given. And first, you have to compute for K, which we just did a while ago. Next, apply the formula for half-life. Okay, class, here's an asynchronous activity for you guys to answer. Now, class, let's talk about area under the curve, what we call the AUC. So it relates the rate and extent of drug absorption, and it determines the amount of systemic drug absorption is directly related to your AUC. So basically, class, whenever we compute for bioavailabilities, ginagamit natin si AUC. And the units you get here, class, is microgram hour per ml, or microgram per ml per hour. How much of that was absorbed? Now, there are 3 methods, class, na ginagamit natin here. You have the counting method, trapezoidal, and then the blood level equations. In our case, okay, normally, class, we use the blood level equations. So the more data available, the more accurate the estimate of the AUC will be, obviously. Okay, scarcity of data during the absorption phase and around the peak time will result to an underestimated AUC. And scarcity of data during the distribution and elimination phase will result to an overestimated AUC. So how do we compute, class, using the trapezoidal rule method? Okay? Ang gagamitin natin kasi dito, class, na formula is the formula for an area of a trapezoid. Okay? The area of a trapezoid kasi, class, its formula is y2 plus y1 over 2 x2 minus x1. Okay? That is the formula for an area of a trapezoid. Now, what is a trapezoid ba, class? A trapezoid is a figure wherein 2 sides are parallel. 2 sides can be parallel, while the other side is not. That's a trapezoid, right? This is a trapezoid as well. Correct? Now, class, if you look at the plasma level time curve, okay, if you look at this, class, yung shape nito is a trapezoid. Here's another trapezoid, another trapezoid, another trapezoid, another trapezoid, another trapezoid. So, ang gagawin ko lang dyan, class, is I'm going to get the area of this, area 1, area 2, area 3, area 4, area nito, saka yung area nito. And then I just add everything up and then you get your area under the curve. I'll just sum it all up. Add ko lang lahat to. You get your AUC. So basically, class, when you compute for AUC from 0 to TX, ibig sabihin from 0 time up to whatever time it is na meron ka lang data, this is one area. Here's area 1. Plus area 2 plus area 3. And so on and so forth. Okay? So, big sabihin class, pinagsasama-sama ko lang yung different areas na makukompute ko dito to get the area under the plasma time curve. Okay? Kasi ang Y2 here will just simply be your C2 plus C1 over 2 divided by T2 minus T1. So, I hope that's clear, class. Now, that's from AUC from 0 to the last concentration that you have. So, that's TX. Now, of course, class, may remaining area tayo dyan. When I say remaining area, ito yung last point mo, hanggang dito lang. Okay, paano naman yung area dito? Pagdating class sa area na to, yung natirang area na to, we call this the rest area or remaining area, we just assume that value. And to get that value, class, you just simply divide your terminal concentration, which is Cx, by your K. Whatever value you get there, class, that is the AUC from Tx to infinite time, meaning whatever time it may be. Okay? Now, to get AUC from 0 to infinite time, you just simply have to add AUC from 0 to Tx and AUC from Tx to infinite time. So you get AUC from 0 to infinite time. Okay? Okay. So ito yung remaining area, last area. Sabi nga, it's just the terminal concentration divided by your K. So let's have a sample problem here, class. Mabait yung mabait yung problem na to. Binigay na agad sa atin yung C sub 0. Pero again, if it's not given, class, then you can always compute for this. Or you can extrapolate it. Gusto nyo mag-graph, walang problema. You can do Microsoft Excel. Okay, but of course, I won't require you to do that here anymore. Okay. So class, di ba ang sabi natin, ang area of a trapezoid is C2 plus C1 over 2 times T2 minus T1. So now, class, ang question dito is AUC from 0 to infinite time. So meaning I have to get my AUC from Tx to infinite time pa. And ang starting ko should be at 0 time. So again, I'm given here at 0 time. Now, when I'm given a problem like this, class, ang una kong ginagawa is pinagsasama ko muna to. Okay? So, kinakategorize ko yung mga to. Okay, because I know this is equivalent to one area. So, that's 6.7 plus 6.0 equals 6.7 plus 6. 12.7. Well, duh. 12.7. Tapos, guys, i-divide ko siya by 2. Kasi ito yun, no? Ito yun. So, kumbaga, unahin ko muna yung values na to. Then, susunod ko to. Okay, so 12.7 divided by 2, we get 6.35. Now, dito naman, T2 minus T1, so that's 0.5 minus 0. So, 0.5 minus 0, and we get still 0.5. Okay? So, ganito gagawin ko sa entire process here. Unahin ko muna itong nasa y-axis. So, 6, 5.3, 5.3, 4.2, 4.2 to 2.6, and 2.6 to 1. So, 6 plus 5.3 equals, that's 11.3 divided by 2. Get 5.65. Next one. 5.3 plus 4.2 equals 3 plus 4.2, 9.5 divided by 2, 4.75. Now 4.2 plus 2.6, 4.2 plus 2.6, we get 6.8 divided by 2 gives us 3.4. And then lastly, 2.6 plus 1 equals 3.6 divided by 2. 3.6 divided by 2, you get 1.8. Okay, so yan yung sa side nung sa plasma concentration. So dito naman, okay, 1 minus 0.5, you get 0.5. 2 minus 1, you get 1. 4 minus 2, you get 2. 8 minus 4, you get, well, obviously, 4. Okay? So, dapat class, kung ilan yung values nito, like 1, 2, 3, 4, 5, 6, I have 6 values here, I should be able to compute for 5 areas. Right? And that's 1, 2, 3, 4, 5, good. 1, 2, 3, 4, 5, good. Okay? So, both sides, okay na, 5 sila kasi I have 6 datas. Okay? Palitan ko lang yung color nito. So, now, class, ipagsasama ko na sila. Again, you can have your own, excuse me, you can have your own technique here. Okay? It just so happened, this is my technique. This is the technique that I use. So, tapos kasi, ipagsasama ko sa by multiplying both sides. So, 6.35 times 0.5. That's area 1. So, this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4. Lagyan natin ng label para hindi tayo malito. Okay? 6.35 times 5.65 times 0.5. 4.75 times 1. 3.4 times 2. And then 1.8 times 4. 6.35 times 0.5. 3.175. 5.65 times 0.5. 2.825. Oops, what's that? 4.75 pa rin yan. 3.4 times 2, 6.8. Then 1.8 times 4, 7.2. Combine everything. So 3.175 plus 2.825 plus 4.75 plus 6.8 plus 7.2 equals 24.75. Dito lang sa gilid. I did not. 24.75 microgram hour per ml. Now, this is my AUC from TX to, from 0 to TX. Ang tinatanong dito, class, is AUC from 0 to infinite time. So, I'm not yet done. I need to get my AUC from TX to infinite time. And that's usually the terminal concentration divided by the K. K. Ngayon, wala pa akong K. Right now, I don't have yet my K. So, let's compute for my K. Whenever, class, you're given a data like this, normally, ang ginagamit natin to compute for K is the last terminal points. Meaning, 2.6 and 1 ang gagamitin ko. In my case, ha? Bakit ko ginagamit yung last terminal points? Kasi at this point of in time kasi, class, medyo stable na yung elimination ng gamot. Okay, it already achieved equilibrium, kumbaga. Alright? So, let's compute K. So, that's Ln. 1, 2, 3, 4, 5, 6. LNC6 minus LNC5. Itong dalawa yung gagamitin ko. That's T6 minus T5. So, Ln, what's my 6? Unahin ko 2.6, minus Ln1 divided by 8 minus 4. Ln 2.6 minus Ln1. Sorry kasi diretso ko na. 0.95551 divided by 4. Our K here, class, would be 0.2389 per hour. That's K. Now, let's compute for AUC from TX to infinite time. What's our Cx? It's 1. 1 divided by 0.2389 per hour. So 1 divided by answer. And you get 4.1862 microgram hour per ml. Okay, this AUC from Tx to infinite time. Now, ang question is AUC from 0 to infinite time. So that means it's simply just the addition of 24.75 plus 4.1862. You get 24.75. Ano ba yan? 24. Nagkamali naman ng pindot. Ulit. 4.1862 plus 24.75. 28.93. 9362 actually. That's, milligram R per liter pala to, sorry. Well, same lang naman yun, microgram per ml. Alright? So, pretty much, we got the same answer here. Now, may bonus question siya. Papakompute ng, clearance. Compute for clearance daw. Now, if you still remember, class, when we compute for clearance, which we discussed last meeting, clearance, class, is just simply VD times K. So, here, class, we don't have the value for VD yet. We don't have the value for VD yet. So, ngayon, class, papasok ang equation na ginagamit ko kadalasan. Sabi ko, huwag niyong kakalimutan, which is Cp sub 0 equals dose over VD. Kasi, class, pwede ko makompute ang VD ko as dose over Cp sub 0. Do I have the dose? Yes, I do. It's here, written here, 80 milligrams daw. Do I have the Cp sub 0? Oh, yes, I do. 6.7 milligrams per liter. Okay? So, therefore, class, ang dose ko is 80 milligrams divided by 6.7 milligrams per liter. So, cancel. Ang lalabas ay 80 divided by 6.7. Okay? Ang VD natin would be 11.94 liters. Now, that's just the VD. We're not yet done. Kasi ang hanap natin is clearance, which is VD times K. And that's 11.94 liters times RK, which is 0.2389 times 0.2389. And we get 2.85. Liters. Which is this one. Alright? Get 2.85 here. Okay? I hope that makes sense. Okay. So that's the long method of doing this calculation. Now, of course, class, ayoko naman nahihirapan ng mga estudyante ko. Char. Okay? Now, class, because I've actually made a Microsoft Excel sheet. Now, please don't mind the other routes here. Ginagamit ko ito whenever I'm computing for bioavailabilities of certain drug products. Comparison. Okay? Pero kasi I made here a Microsoft Excel sheet to simplify or to help my students, or actually for me, whenever I'm comparing the bioavailabilities of certain drug products. Okay? Kung sasabihin ko, maganda ba ang relative bioavailability niya o hindi. So anyway, class, this is how you use it. Now, let me just show you the larger scale of this. Okay? Ito yung tsura niya. Okay? Now, ang titingnan lang natin is yung final bioavailability na compute for drug 1, or route 1. Ito lang titingnan natin, ha? Okay, kasi again, I'm using this Excel sheet whenever I compare various bioavailabilities. So, let's write here first the time. 0, 0.5, 1, 2, 4, and 8. And their corresponding plasma concentrations. That is 6.7, tapos 6, 5.3, 4.2, 2.6, and 1. Okay? Ang next question niya dito is, ano yung peak concentration na gagamitin ko? So, in my case, class, pipili ka lang naman ito kahit anong concentration ang gagamitin mo. Pero gagamitin ko, class, is yung ano na lang. 6.7? Sige, gamitin 6.7. Pwede naman. 6.7, and then ang last ko is 1. So, ang time niyan is 0. Ang time nito would be 8. On the 8 hour. So, class here, computed na yung aking K. Elimination rate constant, which is 0.2378. Try nga natin, gamit natin yung ginamit natin kaya. 2.6. 2.6 at saka yung kanyang peak concentration. Ang time niya dito would be 4. See? 0.2389. So, pretty much the same, right? Here, 2.2389. Okay? Pero sige, let's stick with our original one. 6.7, saka ang peak is 0. Pretty much the same. Okay? And voila, class! Already, I have my answer, which is 28.9559. Okay? Pretty much the same. Okay? Iba lang kasing value sa ginamit ko. Pero, you get the same answer, right? Okay, so obviously, class, ang diniscuss ko for almost 30 minutes, I just did it in a few seconds. Okay, so yun na yun. AUC from 0 to TX, TX to infinite time, and then of course my AUC from 0 to infinite time. Okay, so yan siya. Here it is, 28.9559. Okay, I'll provide this to you guys. Pero when, kasi may mga, ano tayo dito? May mga sample problems tayo here. Okay, which of course, I'm going to make it as an asynchronous activity for you guys. I want you to compute it using the long method muna. And then class, verify your answer using the Microsoft Excel sheet. Okay? Yes, that's pretty much our discussion for basic pharmacokinetics computation. So thank you very much for participating, class. Now, see you guys next meeting. Bye. All right, so good morning, everyone. So for today, class, we will be discussing about elimination rate, half-life, and area under the curve. Okay, so basically, class, last meeting, we were able to discuss some few concepts, okay, some terminologies na dapat aware tayo, okay, before we can start class with our computation. Okay, now, one thing, class, that I need you guys to be reminded of is that since most of our drugs, class, available in the market, yung kanyang therapeutic concentration does not reach saturation. Hence, class, our discussion here will focus more on first-order processes. Sa mga first-order muna tayo. Okay? Limited lang kasi, class, yung mga drugs that follows zero-order kinetics. Yung kung saan, class, ang therapeutic concentrations nila is near the saturation point. That's why, class, we're going to give more attention sa first-order process when we do our computations. Especially, class, in the latter parts of our lectures, okay, of this course, okay, we will be discussing more on first order process talaga. Sisingit-singit lang natin ng konti yung zero order process, right? So I hope you won't mind, class, during the entire discussion here, I'll be focusing more on first order process. Pero again, isisingit ko naman yung zero order process. Okay? All right. So elimination rate constant. We all know, class, that once a drug enters the system, it's going to be eliminated sooner or later. Now, of course, class, whenever a drug is being absorbed, at the same time, it's going to be eliminated at a constant rate. Okay, provided, class, that the drug, again, is following first-order process. So, an elimination rate constant, class, represents a fraction of a drug removed per unit time. Now, please take note of the term. The elimination rate constant represents a fraction. Kaya, class, you'll notice, ang unit ng rate constant natin, elimination rate constant, is like 0.05 per hour. Okay? Notice, class, wala ditong milligrams per hour, ml per hour. Walang ganon. Kasi what we're given here, class, is a fraction of the drug that is eliminated with respect to time. So, pag sinabi natin, class, 0.05 per hour, it means 5% of the drug is eliminated every hour. Okay? So, it just represents a fraction of the drug that's being removed. It's not an exact unit. Kumbaga. So it just tells us this amount is being eliminated in a given time. This fraction of the drug is being eliminated at a given time. Right? So the first order process is applicable or of greater use for us here Okay, as compared class to the zero order process, because first and foremost, most of our drugs, again, about 95%, their therapeutic concentration is not near their saturation point. So most of our drugs do not experience saturation at therapeutic concentrations. Hence, class, they follow the first order process. Okay, ilang gamot lang naman, class, ang therapeutic concentration niya ay malapit na malapit sa kanyang saturation point. Right? Now, how do we compute, class, for our elimination rate constant and so on and so forth? Okay, so basically, class, ang ginagamit natin dito is the equation of a straight line, which is y equals mx plus b. This is something taught to us, class, nung tayo ay high school pa lamang. Okay, when we were doing geometry. Where in class, we plot, okay, we make straight lines in a cross-sectional graphing paper. Okay, we're in class, y-axis, obviously, dito yan. Okay, dito sa side na to. This is our y-axis, and our x-axis, class, would be written down here. Okay, ang increase niyan, class, would be, of course, this is the 0 point. 0 point nandito. So, tapos increase tayo pataas for the y-axis. Then for the x-axis, pakanan. Right? Now, ang turo sa ating class is y equals mx plus b, wherein the y class here refers to any data on the y-axis. Okay, obviously here. Alright? And then yung x naman, class, is yung mga data na nandito sa x-axis, obviously. M here, class, refers to the slope of the line. Okay? So, wait lang.